Hi, thank you so much for making time and joining me on the Saturday evening. I
Yeah,
appreciate that.
yeah. It's a pleasure from my side.
It's just to give a quick introduction with you, but before I let you introduce yourself, I want to say that I just recently came from two big projects, retail banking and business banking, that we actually hosted it on OpenShift,
Mm,
and we had some problems, but you guys really was very helpful. I
mm.
appreciate the help that I received from you guys during that time. So I'll leave it to you now, Stefanus. Please take it
Okay,
from here.
okay. Thank you very much, Chris, for the opportunity. So I think to start with, let me introduce myself. My name is Stefanus. I've been with Red Hat around, I think, more than 8 years. So throughout those times, I experienced, I think, two two big change from OpenShift version 2, 3 to 4, right? So it's a big jump, and I think at first also from our side from Red Hat, we do a lot of bets in OpenShift, and I think it pays off now. And again, I think one of the testimony is coming from your side yourself, right? I think you are using it, and hopefully it's delivering the value that being promised initially. So I think yeah, to save some times, let me share my screen now.
Yeah,
Um,
we can see your screen. Yeah.
Okay, okay. So I think to save the times, I will start the session today. Thank you very much, Chris, for the opportunity. So I think for today, the topic itself, as we can see here, the title, right? Manage application platform to achieve the open hybrid cloud. I think there are two things that we're gonna discuss in sequentially, right? So first of all, it's about the open hybrid cloud. This day, we do see that the implementation of hybrid cloud is not just a myth, right? Previously, I think 3 years back, or probably 5 years back, right, when we heard the word cloud, it seems too cloudy, right? And then it have many kind of meanings, depends on who is mentioning about cloud and what is the definition of that. But I think this day we do see public cloud as becoming more and more common to be implemented and to be used by the enterprise, right? And not only that, I think many kind of usage for the public cloud itself, either having the full kind of implementation like what the company has been doing on the DC, and then they use it as a DR, for example, or some of the companies we do see some of startups even do a whole deployment on the public cloud, right? So I think the cloud era is already here, and it still makes sense to implement the hybrid cloud implementation. So not everything to be deployed on the public cloud, but some of it probably still on the on-premise. And then how do we actually manage that? And hybrid cloud also covered not only on-premise and public cloud, but also we do see these days public cloud implementation usually it's not only a single cloud vendors. We do see also implementation of a multi-cloud implementation. So that concludes also the hybrid cloud. Right? I think the second part here is the managed application platform. So I think throughout this session, I will try to explain what is the application platform itself. And then the interesting thing in here is there's a offering called managed application platform. So after we understand what is application platform, what is the difference between infrastructure as a service, platform as a service, and the application platform itself, and by having it to be managed service, what kind of benefit and value we can gain from that. Okay, I think without further ado, let me start the session today. Yeah, to make it uh, uh, attached with us, right? Sometimes when we come up with a solution or a product, right, we definitely need to see what is the problem statement that this solution will able to address, right? So I think we do see these three common problems being faced day by day by the IT teams from the business point of view, right? So I think this day the requirement itself, how the IT need to support the business, the expectation is becoming higher and higher day by day, right? While at the same times, The bad thing is I don't think the IT division itself is being given like a whole bunch of money and the authorities to hire hundreds of army troops to manage the systems, right? So that's only a dream. So what we're gonna face is the expectation is getting higher, but we need to work with our current capabilities, our current limited time and also limited resource, right? At the same time, with this all new development about the cloud native, we implement with public cloud and then how we move around with that. Whether we like it or not, we do also have the legacy system that we need to manage. Right? And then how we can actually manage the complexity between these two environments, whether the newest kind of things in the public cloud and also our on-premise, sometimes even a couple of workload is not even virtualized yet. Right? So this is the common kind of a problems that being faced day by day by the IT team. Right? So yeah, first of all, after we seeing the problem statement, we do actually see is that how we can address all of these problems. One of it is by implementing a hybrid cloud environment. So I think the solution itself consists of three main components right in here. I think first of all, we do agree that with the limited time, definitely we need to develop an application or solution faster. So as we can see in here on the green box, right? One of the main components is definitely how we can actually create an application faster than we did yesterday, for example. And at the same time, when we enroll this in production, we need to make sure that it can scale. So this kind of cloud native kind of application usually have the plasticity or the capability to be scaled in and scaled out easily. And that's what we want to get from this new solution. At the same time, definitely we want the infrastructure or the platform underneath our solution to be stable, right? So it doesn't really make sense if it is running really fast, can scale really fast also, but at the same time, it's brittle, right? It's easily to be probably the security part is not that solid, right? So it doesn't really make sense to say. So what happened when we do want to implement this kind of solution, we need to make sure that there is a balance between these three components, from the development, operation, and also the architectural part. So as we can see, our solution, the ideal one, is can be implemented in many kind of environment. So this is where the hybrid cloud coming into the picture, right? So the solution itself can be implemented either on premise, or either we want to deploy it on public cloud, or even for next kind of generation application, it's for example the IoT kind of solution, right? We want to do it on the edge, right? Um, so the concept of open hybrid cloud itself is, like I mentioned earlier, is how to actually we try to balance these three components from the architecturing point of view, from the developing point of view, and also from the operational things. So how we actually try to balance it, and then we gain all of the benefit by making sure that it's not compromising between one and the other. We gonna gain the speed, stability, and also the scalability out of the solution. At the same time, definitely it will help on doing the digital transformation process, right? So I think these two slides, right, that we seen is still really theoretical, like it's really cloudy, right? And how do you actually implement this framework into a working kind of solution? So when we try to map all of these three components, then this is what the common kind of implementation being happen in couple of customers, right? And also a couple of enterprise. So definitely in the red box, we can see in here is on the stability itself. It's more focused on the infrastructures. So either it's going to be implemented on premise, either a bare metal, virtualization, or even a public cloud, right? So we can see the spread of public cloud is being available, I think, these days. I think the most common one, AWS, Google, Azure, even Ali Cloud, or even IBM Cloud, right? And other quite unique kind of environment like an edge, right? Or even in local, definitely there are a couple of local public cloud providers. How we can actually gain benefit out of that by leveraging a solution that can be implemented on those environments. And I think without a doubt, these days, if we are talking about an application platform or a platform to develop the application, right? Everyone is talking about containers. And if it is containers, I think as a definite orchestration platform that we see these days is being widely implemented is definitely a Kubernetes, right? And then on top of that, more focus on the developer experience is definitely how the tools can help developer productivities. And we do see here a couple of box leveraging the middleware stack, right? Either doing enterprise integration, leveraging API, for example, creating an ESB, and then application runtimes and services to help develop the application itself. And also next is the data services. How can we manage the data management? At the same time, how do we make sure that all of this will work standardly and systematically during the operation? Then we have the blue box in here, which is usually include the automation piece, right, to help on the operation day by day. And one of the most important characteristic when we talk about hybrid cloud, because we are going to involve with different kind of environment underneath, right? Either it's going to be on premise, public cloud, or often over the edge, right? Then what importance here is how we can make sure that any kind of environment our solution is being implemented, it's going to be consistent. So the keyword here is open hybrid cloud definitely mandates consistency on any kind of infrastructures. So I think from these days of sessions, right? If there is only one thing that from myself I want you to put as a takeaway, then that's going to be this this concept, right? Hybrid cloud mandates consistency on any kind of infrastructures. So if you want to success in doing the hybrid cloud implementation, definitely we need to think about how our solution can be consistent. Okay, so that's quite a lot about the hybrid cloud, the concept of it, and also the framework about how we try to implement the open hybrid cloud in multiple kind of infrastructures. Let's move on into the application platform. Right? So before that, we see here as the glue, right, between the developer and also development and also the architecture is the Kubernetes. So this one is quite interesting, right? Let's start with a fact. If we want to do an implementation of Kubernetes, actually it's not that easy, even though there are a lot of things that has already been automated by Kubernetes, has already been standardized by Kubernetes, but actually Kubernetes is not the one panacea doing everything. Right? If you want to do implementation for native platforms, Kubernetes is one layer of it. But definitely there are a lot of things that you need to think about when you want to create a platform out of a Kubernetes, out of a vanilla Kubernetes, right? So you need to think about how you can try to standardize the installation method. Then how do you going to automate the deployment? Then most of the works is going to be on the day two, right? How do you do the operational later on? So for doing the logging, monitoring, it's not come out of the box from the Kubernetes. Definitely, there are a lot of third-party or other open source project that can be integrated with Kubernetes. But you need to have those kind of skills to orchestrate the whole thing to create it into a platform. Right? So the statistic that we get is almost 75% of the enterprise users sees this as a challenge, right? When they want to just implement vanilla Kubernetes and then maintain it by themselves. So there are a lot of example where just a standard plain vanilla kind of Kubernetes implementation gone south, right? One of it is even for Tesla. So it's quite common. This is quite common where if we want to do just a simple Kubernetes and when we want to scale, then it's going to be a problem later on. So this is a eminent problem that we see everywhere, right? So that's why it came into a picture an application platform instead of just a container platform, right? Instead of just a Kubernetes, that's it. So an application platform, what is the difference if we see is about application platforms and also a Kubernetes-based solution, right? So application platforms, it will definitely focus more on the experience, either experience from the developer side, from the operational sides, and also from the security team, right? So the main focus is how an application platform could be used, could be implemented to help the developers. Definitely those kind of activities, including how the application platform could automate the runtimes, including the build tools to help them to do the developing day by day, including CI/CD and also the day-to operation from the operational side. So doing application logging, for example, doing monitoring. So those kind of stuffs, it's included inside of the application platform. So a complete application platform, probably inside of it, there's a Kubernetes that helping probably like 50% of the works. But definitely the focus here is not the Kubernetes itself, but the application platform. So means the user, either from developer side or from the operational side, they don't actually really knows that this solution is using Kubernetes, but what they need to focus on is their day-to-day job. Right? So they don't need to be a system admin, know quite details about how Kubernetes work, how it going to operate and integrate with other third-party solution. But what they need to focus is, for example, for developers, focus on the code. For operational, just focus on the lifecycle of the application platform, right? So a good application platform would actually abstract the Kubernetes component out of the end user. Okay, so yeah, it's one interesting topics about application platform. So usually, I think we do agree from developer and operational, right? Sometimes these two organization would have contradictive kind of main goals. So sometimes from the developers, more focus on how to develop the application faster, right? How they can try to have more release, and then how they can get a faster lead time. While from the operational, definitely what they want to focus is to make sure the system is and the infrastructure is stable enough. And then if there is something happen, then they will have small time to restore it. So sometimes it's an option whether we focus on the throughput or stabilities. So what app platform try to balance between the main goals of the developers and also from the operational by trying to abstract couple of the mechanism. So from the operational, they will have less less workload to think about, and then more focus on making sure the platform is stable enough. And definitely because almost everything is being automated, then less manual job need to be done if there's something happens, right? If there is a problems. At the same time, from developers, because all of the mechanism from the application platform already include the building tools, for example, already include the automation of the CI/CDs. So this thing will definitely help them to develop application faster. So now with an application platform, actually, it's not a choice between throughput or stability, but both can be achieved together. Okay. So I think talking about this concept of application platform, how it can uh, translate it into a real products. From Red Hat, our products that being placed in the application platform is OpenShift actually. So OpenShift, even though it is the main component of it is actually Kubernetes. But as an application platform, customers don't really need to have a direct interaction with the Kubernetes itself, right? And then there are many components that making it as a complete solution, and that's OpenShift. And one of the important characteristic in here as an OpenShift, it's consistency. So when we see about the concept of open hybrid cloud, the same with the requirement, OpenShift actually can be deployed consistently in any kind of platform, starting from bare metal, on-premise, or even public cloud. And public cloud, not only the big names, like in here, as we can see in AWS, Azure, Google Cloud, IBM Cloud, or even some of our local public cloud, as long as they are following the standard required by the OpenShift to be run. Right? So what we can see in here, OpenShift actually one of the main component as a baseline. How do we actually develop our solution in a hybrid cloud environment? And another interesting point is the ROSA, or Red Hat OpenShift services on AWS. So ROSA is the additional missing piece of puzzle, right? When we already knows, okay, OpenShift is going to be the way to develop my application, either it's on-premise or public cloud. And also we do see a lot of our customers these days, they don't have um, the um, the resources and also time to maintain the platform itself, because the focus is definitely on the application, right? So for those kind of requirement, then ROSA, or the managed service for OpenShift on top of AWS, is one of the main value proposition that can be positioned there. So the great thing about this is it's really only took couple of minutes to provision the cluster itself. So compare if we are doing a managed OpenShift by ourselves, it requires probably days of architecturing, creating the design, and then doing the deployment itself, doing the hardening. But with this, because it's already becoming one of the catalog in the marketplace on AWS, it's really easy to deploy. And then the good thing is there are a managed service portion in here. So that's why, because it's a joint managed service from Red Hat and AWS, we have a dedicated SRE to manage the platform. So we can maintain an SLA 99.95% to the end user. And the good thing is with this solution, it's a consumption-based pricing. So means if you do have some application to be tested, right? Previously, if you want to test on OpenShift, you need to have the full platform to be deployed, right? So waiting the time to be deployed, or we are using our existing OpenShift. So with this, it's within the minutes, you can provision the clusters, you can test whatever you want to test, and then you can shut down the whole things, and then you don't need to be charged on anything. So if you only need to test 3 hours, then it's only 3 hours being charged. And the good thing is the pricing and the billing is not going to be split between Red Hat and AWS. You only need to do the billing only on the AWS. Everything is already included on the AWS. So it's, if you can see in here, so you get the benefit of the platform itself, the OpenShift, and also you get the additional value of the managed service from the SRE, and then the flexibility that will begin from this, right? So as illustration in here, if you are deploying your own OpenShift clusters, right? So there are a lot of things that you need to manage day by day, right? Only the platform support coming from Red Hat, definitely. Something happened, troubleshooting, and then there's a problem, patch and everything, it will be handled by Red Hat, right? But if you are doing the ROSA, as you can see, the abstraction level is going up until the deployment itself, management, monitoring, and logging, everything will be done by our SRE. So the main focus is only on how to use the platform itself. So in here, for example, how do you manage the user, project quota, and also application lifecycle. So by having this, definitely it will save a lot of times, save a lot of effort, and you don't need to have a dedicated resource or maintaining the day-to operation of the platform. Okay, so if you use an interesting analogy that being widely used sometimes, it's a car analogy, right? So if you are asking what is Kubernetes, then it's an engine, right? It's the engine itself. And then the XKS, usually, if you see on a couple of the public cloud, they have their own Kubernetes kind of services. So it's actually a Kubernetes with an additional parts. But what happened in here, if you have all of these parts and also the engine, you need to build it by yourself, right? So it's not a complete ready to be used kind of a solution. So you still need to have your skill to create it as a car. So difference with the OpenShift, it's an assembled car. So it's ready to use. Just have the access and then you can use it. That's it, right? But there's also an additional layer. If you cannot drive, right, then you have the full surface, for example. We can take example for Uber, for example, right? Uber or Grab. Then someone with the skill will help you on doing the actual day-to-day kind of operation, right? You just need to sit down and then enjoy the ride, right? With the support and operation in here. So this is as an analogy that we can use. Okay, so probably I will not go drill down quite detail in here. So sometimes there are an objection about the costing. So actually the good thing with this kind of solution is already included everything. So sometimes there are some kind of intangible kind of a portion that is not being put it in. So that's why sometimes our solution seems like it's pricey, right, or overpriced. Sorry. So I think to save some time, let's get into the end of the topics itself. So what is the actual benefit that we can get? Definitely is the developer productivities. So developer don't really need to wait for times to cluster to be up and running, and then making sure that it is being updated into the latest, waiting from the operational staff. They can do it by themselves by having the self-service, right? Operational costs, definitely, because there are SRE that could help on doing all of those stuff, and we only need to focus on how to use the platform. That's it. Doing upgrades, updates, it's going to be fully maintained by the SRE. So definitely it's going to reduce the operational complexity and flexibilities. Again, you only need 3 hours, then you can just spun it in a couple of minutes. You're gonna get your full clusters. You don't need any more, and then you're just going to shut down, and you only going to be built within those 3 hours. Okay, I think another studies that being done by Forrester in here, it shows a couple of really good features about what is the benefit using the managed application platforms. Specifically in here is ROSA. Then yeah, definitely from the illustration that we've seen before, we can definitely see what is the benefit that can be gained here. I think as a closure, so ROSA definitely could give the turnkey application platform. So turnkey means we just have the keys and then just turn the keys and everything will just work as accordingly. Accelerate the time to value, because now to even provision the cluster itself only took minutes, and the day-by-day kind of an operation is being leveraged to the SRE. We only need to focus on how we can maximize the use of the platforms. And the SRE itself as an expert management and support. So you don't need to think about the platform, whether it needs to be upgraded into the latest version, for example, whether it needs to be integrated with other AWS component. It's everything going to be managed by AWS and also Red Hat. So I think, yeah, that's all from my side today. So hope the topics is going to be useful for you. Okay, over to you, Chris.
Thank you so much, Stefanus. I know we are running out of time as well. Once again, thank you for being online on Saturday, and also thanks a lot for helping me in my last two critical projects that I had on OpenShift. Red Hat, and you helped me a lot on that. Without you, would definitely would have failed. Thank you so much. Have a good weekend. Take care.
Thank you, Chris. Bye-bye.